So originally I had this idea of making Minecraft inside of Blender, not using the Blender game engine alternative UPBGE, but instead making it run entirely in real time in geometry nodes. This is going to have things like walking around the procedurally generated landscape. Maybe you can hit blocks and collect items. I think crafting would be an insane amount of work, but that's the idea. Maybe I'm going to make a course for it. Maybe I won't. I love generating false hope. Anyways, what we are going to do today is kind of do like a alpha of it. Try to get the bare bones of it as kind of like a proof of concept where you can see how one might make, Minecraft inside of Blender. Next, we're going to be making Blender inside of Blender. So hopefully Hopefully I've shown some footage of what this is going to look like by the end of this video, which will keep you around because this video is sponsored by Squarespace, and we are going to talk about Squarespace right now. So imagine you want to make a website. Maybe you're promoting your Minecraft inside a Blender game. It doesn't matter what you're doing. Making websites is complicated. You might need to learn to code and kind of a pain. This is where Squarespace hops in and basically turns the website development process into something simple, basically taking templates, moving them around. Everything is a square or a block, aka Squarespace. 3 features that you might want to know about Squarespace is 1, it comes with all your analytics data, just as YouTube does as well. The analytics show where people are coming from, how many people are there per month. Another feature is the asset library that I love, which will basically be a cloud drive for anything you upload on your website, any video, image, whatever. It will save that. And then the final feature, which is kind of like the whole point, is making websites is easy with drag and drop kinds of templates. So I would call that a feature. So you can head over to Squarespace and try making a website for whatever your use case is, and when you're ready to take that thing live, if you like it, you can use my link in the description to save 10% off your first purchase of a website or domain. Okay, so that has been said, and now we're going to completely pivot, and we are going to make Minecraft, at least an alpha of it, inside of Blender. So my screen capture looks good. Maybe make the face a tiny bit smaller. Here is how we do. So kind of the hardest part of doing this is actually not generating anything. It's actually doing the walking, jumping, whatever mechanics. So I'm going to show you, first of all, a shortcut to do that. So let's save our project in case Blender crashes. And I haven't been getting many crashes recently, so I'm happy with that. Walking system is going to be the hardest, but it turns out that even though this is not the game engine version, there is a nice way to combat this. So I'm just going to make a tiny bit of a kind of like a gaming level or something like that. So imagine there's a plane with a single step, and we want to kind of walk around this terrain. Well, you may or may not have known that there are different kinds of navigation types inside of Blender, or kind of viewing types. So if you go to View, Navigation, you'll see all this stuff, but particularly Fly and Walk navigation. If I go to Fly navigation, it kind of behaves like a video game. As you see, I'm using WASD to kind of, move around and the mouse to look around. It's very finicky. I would not recommend it. It has too much acceleration and stuff like that. So instead, we are going to use, and this would make more sense for a video game anyways, you click to stop the navigation. We're going to use walk navigation, which to me, it's kind of the same thing, but it's more intuitive. So you move around like you would in a video game. You scroll up to increase your average speed, because sometimes you want to move faster. And the coolest part is if I hit tab, you can see there's gravity and I'm walking around my game. Now I believe jumping is a little weird. I'm trying to remember what the key for it. I think it is V. Well, all the information's down there. You click V and you can jump. If your jump is not tall enough, we're going to need to increase our jump height. Hopefully, okay, so it's going to be period and comma. Let's hit period a few times more. And you can see every time we're jumping more and more and more. So the walking thing is kind of built in. One major issue that I kind of want to ruin your, or I don't want to ruin your, rose-colored tinted I don't know. You can walk through objects. There's no collision except for the ground, but we'll make it work. So now I've jumped up on a platform, and now I'm moving down. Physics are kind of weird. I wonder, by the way, I'm not sure about this, if I go to the scene gravity, and I maybe invert this, will I float up? I'm not sure. So I'm on walk navigation, or no, I'm not. So I have my gravity, and I jump. Okay, it doesn't seem to care about that. So there you go. We've all learned something. So the point is, now we don't need to worry about, it's kind of weird doing normal navigation after that. We don't need to worry about our navigation. We have that built in. So let us build some terrain. First of all, what is the idea of our terrain? Basically, I'm going to make kind of like a block, maybe a 64 by 64 chunk, where each kind of like cell in here. So imagine this is not ugly and 64 by 64. Each cell is going to be populated by a block. That could be a dirt block, a grass block, a stone block. We're going to need to create the logic for that. And additionally, each cell is going to have a height. So some blocks might be higher than others. And the main thing we care about is if we have a block, since we're going to have a full chunk without caves for now, I want there to be blocks underneath. So it's not like a one block thick platform, but instead, maybe this one can be higher. We have more of a terrain. So that's the idea. And of course, we're going to do that in geometry nodes. But before any of that, before we do the logic, let's make some assets. So I want a leaf block, or if we do trees, let's do trees. We're going to need leaf, wood, dirt, and grass, I think is what I'm going to start off with. And because all of Minecraft is cubes, you can imagine no modeling to do, which I love. Any excuse, you know? Modeling is definitely a thing you could do in 3D. It kind of, well, I'm just kind of salty that I haven't practiced much, but either way, it's not my expertise. Most of this is going to be inside of materials. And yeah, we're fine using LookDev. We need to make a material that looks like, you know, grass and dirt and all of this. And we are going to do this procedurally, even though you could download the textures. So if you think about dirt, it's basically like on its own, kind of also a subdivision of a block. You have a bunch of squares where some of the squares are brown, some of them are darker brown, etc. Here is how we are going to do that. What you might think is that you might start with like a checker texture, which you can see kind of generates our blocks and we can go higher. But this doesn't give us much control over the cells. It's either one color or the other. We don't like that too much. So instead, I'm going to use a like random texture. In fact, we're going to use white noise, but for now I'll show you with a noise texture. We're going to use a source of randomness and basically constrain it so it looks like blocks. And here's how we're going to do that. I'm going to take the basic coordinate system, which is generated coordinates, is going on X, Y, Z, and I'm going to make it discrete. What does that mean? Well, if I take this coordinate system and I scale it by like 10, you can see it's going to get much brighter because instead of going to 0 to 1, or I guess 0 to 2, no, 0 to 1 on each axis because that's the generated coordinate system. Now it's going to go from 0 to 10, right? So 0 on the x-axis all the way up to 10, so it's going to get brighter and brighter red in this case. It's going from 0 to 10, and then the trick is we're going to take this and we are just going to drop it through some kind of rounding function like floor. What you're going to see is now this is composed of cells because it's going from 0 to 10 on a continuum, and now we're rounding down to the nearest integer. Okay? The important thing about this is if you use this as a coordinate system and you look at the noise texture, now, well, it's looking a bit funky, so maybe we can take this and like scale it back down by like 1 divided by 10. Now you can see we have kind of the pattern. So again, generated coordinates, make it 10 times bigger, round down, and then make it 10 times smaller to, you know, do the thing. So there's our noise texture. We can play around with it. This is one way to go. But I think probably the way I want to go with this is I'm just going to use a white noise texture, which initially is just going to look kind of gray. That's because it's generating a number between 0 to 1 on each point. It's even more than a pixel. On average, it's going to look like 0.5, but if I take this, and we're not going to need to do any more rounding, which I enjoy, or you know what? Well, either way, let me show you this. If you connect it, it's going to not enjoy that because I deleted the scale by 10. So if I do that, you're going to get this. Although, now that I think about it, you can see we're getting these like shading errors. That is an Eevee kind of problem. You've seen Cycles that doesn't have that. And I guess I would like to do Eevee. Oh, damn. I guess I just opened Eevee next, which we're just going to use old Eevee because I don't really know how this works. Whatever. Here's how we are going to do it. So I guess we're going to use the other technique. I didn't necessarily expect to do this, but that's fine. So I'm going to scale by 10, round down, do the thing, and then we're going to plug this as a coordinate system into a noise texture. Okay? To make this kind of higher contrast, what I'm going to do is I'm going to take this range and just kind of compress it a little. So we get something like this. Although now I'm seeing that this also generates the issue. So it seems like it's an Eevee thing, and it's more so how we calculate the flooring. Could we do ceiling? That seems a bit nicer. So maybe rounding down Blender doesn't enjoy for some reason. You know what? In that case, we're doing it on the fly. I'm going to change back to white noise if that seems to solve it. Okay, cool. I learned something too. So there's our thing, and you can think of this as a mask that goes between 0 to 1 on each cell. I'm now going to make this a dirt block by changing the color. So this is going to be our factor that we can mix any two colors with, so you can see how we can make different blocks, and we're going to do other things too. I'm going to make this a nice brown color. We'll edit this in a second, and the other one's going to be a darker version. So you can imagine if I bring down the saturation on both of these, it's going to start looking more like dirt. Although, maybe having some reference would be nice. I just got to kind of hone in the color here. So you can kind of do this however you want. But it's kind of looking... Okay, now we're getting a bit close. I think it was like too red was the issue. So something like that's okay. You can kind of hone it in. I don't exactly know. So right now, I believe this has 10 cells. So 0, 1, or sorry, I'm counting like a computer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I believe, if I had to guess, this is a 16 by 16 instead of a 10 by 10. So I'm going to outsource this to a number that we can change later. And remember, we're scaling it back down by the same thing. Although Blender doesn't seem to mind the way we're doing it now. Just to be sure, I'm going to do the reciprocal of this. Okay, so there's our dirt block. Now that I'm looking at it, that's a bit much. Is it 10 by 10? Is it 8 by 8? I honestly do not know. So I'm just going to pick a number that looks good, I guess. But you could refine this for your thing. Other than that, that is looking pretty good. And I also want to say, white noise texture is very chaotic, so you can literally just, you know, generate new ones if you don't like the look of it. But make sure this is at least... Would two-dimensional work? No, it's a 3D object, so three-dimensional. So there's our dirt block. I'm going to name it. I know this is under my face, but I'm just calling it dirt. And more importantly, we have the dirt material, which we might actually just spawn in materials instead of these objects, but that's fine for now. Okay, I'm going to duplicate this, hide the first one. I'm going to call this grass. And really, all grass is it's dirt with kind of like a blocky green on top of it. So, as you would imagine, all I need to do is in this other material, which I'm going to call grass, is I'm just going to kind of make it green, and then we're going to mix these together. I mean, you could argue, by the way, you could argue that maybe the easiest way to do this is send it through a hue saturation value, such that I can change the color, kind of get that right shade of green, and also make it a bit brighter. We actually have everything we need here. And then the question is, how do we say, not really keep it at the top, but it needs to kind of have this blocky kind of transition? Well, here's how we would do that. As you might expect, if we take our generated coordinates and kind of, I'm sitting on the couch, so I'm kind of bending my stomach. Let's see if I can get more comfy. That looks good. So if we take generated coordinates and split it into axes, we care about the z-axis because it goes up and down. We have that information. And in some sense, what I want to do is I want to kind of pick the height of this. However, we're running into the distortion problem, and it's not blocking correctly with our 12 by 12. First thing I'm going to do is I'm going to solve the noise randomness issue. And I guess I just kind of hinted as to how I'm going to do this. Because I want to break up the border, again, make it more, like this, I'm going to apply a source of randomness. So in fact, we can take a noise texture, and you're thinking, okay, this is random, but how is it going to help us? It turns out, age-old trick. Can't say who created this, I have no idea. But if you take a mix color, and you mix your distorted coordinates in some sense with your original coordinates, it's going to look something like this, and you then want to swap this out with linear light. That's just how this works. You can see we have our, one of these is supposed to be correct, I believe. So you have kind of a mix of your coordinates, as you can see. Kind of hard to tell. Basically, all I'm going to do is I'm going to plug this into the X, Y, Z thing, and this should make it more obvious. So here you can see we're breaking up the pattern, whereas without this, we get something more like that, okay? So the point is using distorted coordinates helps with this, and you can actually change the quality of how this is going to happen. Either way, you can see we're almost there, but we got to make it blocky, and as you might expect, all we need to do is kind of pass this through our blocky coordinate system. So to do this, I suppose all we need to do is I'm going to kind of branch this off. Although I guess what I'm trying to say is we can just use our blocky coordinates here. And now you can see we have that. So I guess I don't need to do all this splitting. Let me just kind of clean this up a little. So in other words, we have our generated coordinates. We make them blocky. I'm going to make that its own thing. And then we're distorting coordinates, yada, yada. In fact, now we have this cool little thing that we can decide how it's going to look. And I kind of want to play with this until it kind of looks right to me. So either way, all we need to do is now kind of go between our dirt and our grass and just kind of mix them together. Again, we're going to work on the color. So I'm going to mix these relative to this factor, connect both of them, and that's inverted, so, switch it, and there we go. That is our grass block. Really, the rest of this is just kind of figuring out the color scheme. Again, if you have reference, it's going to look better. So something like that. Only thing I want to do is kind of change our pattern a little. So I'm going to bring down the detail. Just kind of play around with numbers until it looks right. That looks pretty good to me. I think it just has to be a bit lower. And you know what? Even if it doesn't look great, you can always swap it out later. Okay? Now, by the way, I don't know if every grass block is supposed to look exactly the same. If that is not the case, there's also a cool little trick I can do. So all of this at the end of the day is dependent on our white noise, right? So if I take our white noise and kind of change it, you can see we get different patterns. Because of that, if we kind of shift this per object on an object level, that would be good. So let's think about how to do this. For now, I'm going to use object info. You're going to see what this does is if I make two copies, we can look at the object index or random. Is that what we want? I guess we can check. What I'm going to do just to check this is I'm going to add in, so both of them have this material, I'm going to add in the source of randomness, and let's see if they look exactly the same. It's going to be a little hard to tell, but yeah, you can see that this part is dark, whereas it's not over there. So that's how we can change it on a object per object level. And then the only other thing I want to change is you're seeing that the kind of the mask is the same for each one of these. And again, that is determined by our noise texture. So just like we offset our white noise, we can offset our grass. And I'm also going to do that by the same random number because I don't think it matters. But I think I want to do this only on the x-axis so that it doesn't go any further down. So I'm going to take this, do it on the x, and that looks good to me. On average, I want this to be a bit higher up. And okay, that seems to be working. I guess given this, we might want to update our dirt texture to have this, just because. So very simple. I'm just going to do vector math to add in our source of randomness. So at this point, we kind of have everything we need to get started with the terrain. Again, what I'm going for here is making kind of like a 64 by 64 chunk with hills and a nice terrain, but we don't need to populate it by too much. This is just kind of like a proof of concept. So I'm going to hide all of this, and now let's make a terrain. So for this is going to be our geo objects, make it a geometry nodes thing. And now let's think of our algorithm for how we want to do this. So I think a good way to start is we want it to be 64 by 64. So I'm going to make this, let's see. Right now, if it's 3 by 3, that's actually in the sense of vertices. So we get 1, 2, 3, 1, 2, 3. It actually generates a 2 by 2 grid. So for 64, I actually want it at 65. Okay, and I want this to be the correct size. So before I do that, let's think about this. So right now, the radius in some sense is 1. So it's a 1 in this direction, 1 in that direction. In other words, it's a 2 by 2. So if this is, let's make this nice and procedural. We'll use an integer. If this is 3 by 3, we actually want it to be 65. I can connect this here. And now I basically just want to think about how we're going to do this. So if I make it, let's double it. If I make it 6 by 6, now we have 5 by 5. So I've doubled our thing. If I make this like that, does that make any sense? No, because now it's going to be a radius of 4. So let's think about this. I think we just take the number and subtract 1 and divide by 2. So let me show you how I'm thinking about this. If we have 3 for the vertices, we subtract 1, now we get 2 and 2. You divide by 2, you get 1 and 1. Okay? The reason this is going to work is, again, this is 1 larger than the number of faces. It says 3 by 3, but really it's a 2 by 2. And if it's a 2 by 2, well, let's see if I can explain this. If it's a 2 by 2 and we want each cube to be, if it's a 2 by 2 and we want each cube to be 1 unit long, then it has to have a radius of 1 in every direction, right? So if we have a radius of 1 here and 1 here, then this block, of course, is going to be a 1 by 1. But that actually tells me we need to update something, because our dirt block by default is going to be 2 by 2. So I'm going to decrease this to 1 by 1, and I'm also going to do this for the grass block. And we can actually test if this works right now. So again, you take the number, you plug it in there. I'm doing 1 over 64. So I'm just going to make it 1 less to compensate for that. And then, like we said, I believe we divide by 2. If not, we'll find out very soon. So I'm going to connect that to the size. So this is our generator, and it's getting much bigger. I like that. That looks kind of correct to me. And to check this, what I want to do is I want to instance a cube on every single cell. Now notice that means I want to spawn a cube on every single face, not on the vertices. Although you could probably get that to work. To do that, I need to get the center point of every single face. One kind of interesting idea is I believe the dual mesh node, what it does, let me kind of do an overview, is if we have a cell here, the center of it's right here, what the dual mesh does is it creates a vertex, imagine I drew that well, at exactly the same point. It basically replaces your faces with vertices but maintains the connection. So I just want to check the edge scenario. So it should be roughly here. Okay, cool. So in other words, now our faces have been turned into points such that we should just be able to instance them. So I'm going to instance. I mean, for now, let's keep it simple. We might want to apply more logic to this, but either way, I'm going to instance just dirt to begin with. And let's see what that looks like. Okay, so this is a bit of a mess. Now, I think it's more of a mess than it should be because I think objects are overlapping. That tells me that they're too large, maybe? Or is it just kind of like an Eevee glitch? I guess one way to tell is we can scale these down by a tiny amount and they're still overlapping, as you can see. So it seems like the correct number, this will help elucidate it, is to divide by 2. It makes you think. So let's think about that. So if I divide by 2 here, would it now be 0.25? Okay, that seems correct. So forget everything I said before. It was all nonsense. But that's not a big deal. Oh, you know what the issue is? You know what the issue is? We made our dirt block. We made our dirt block 1 by 1 by 1, which is fine, but its own radius from the center point is now actually equal to 0.5. Does that make sense? So if we now make this 2 by 2, its radius now halfway is going to be a unit of 1, and maybe that will clean up the math a little. So I'm backtracking. I mean, in theory, it doesn't matter too much, but let's see. So if I divide by 2, well, first of all, let's make these a scale of 1. So they should be, it's a little hard to tell. They should be overlapping. Yeah, that's the case, so we want it to be equal to 0.5. In other words, we need them to be larger, divide by 0.5. So I'm kind of inverting it, so now if I make them a bit smaller, perfect. So it's just the reciprocal of what I said. Okay, let's view this. I think this makes sense, because now you have this pattern that doesn't, it doesn't like break up, whereas before, I just want to kind of show what I did. If I didn't add this source of randomness, you'd get this repetition, which I don't remember. I haven't played Minecraft in a while, but I think this is probably the way to go. So now we have a completely procedural terrain generator, and I believe, we'll see, but I believe we should be able to spawn at any size. So again, remember we subtract 1. So this is going to be a 2 by 2, a 3 by 3, a 4 by 4. It's a 1 minus this. Perfect. So let's make a chunk of actually 16 by 16, so it's a bit more manageable. What I want to know, because I actually don't know the answer, is can you walk on this? Because it's actually instances. I'm not sure. Let's find out. So I'm going to do walk navigation. I'm going to enable our gravity. And okay, you can jump. Maybe you can jump a little too high, but you can jump, you can move. Perfect. Okay, so now, and by the way, we could have easily swapped this as grass, which to me is kind of looking, now that I see it in context, it's looking a bit like toxic, So I'm just going to decrease the saturation on that, just a smidge. That's looking much better, and I think also the issue is kind of the brightness here. Okay, so that's looking a lot better. Now, all we need to do is we have to kind of vary this up. So this is very easy to do. So again, what we have is we had faces, but we swapped this with the system of points. And what I want to do is I want to have some points go up, some points maybe go down, and then it should create a stack of blocks underneath it. So I guess that's not a big deal. So because we are instancing on our dual mesh, all I need to do is I need to move our points, which will hence move our blocks. But the question is, how much should I move them by? You can't move them half a block, right? You have to move them by a factor of 2. Is that the case? Yeah, that makes sense. So the blocks end here. If I bring them up by 2, then that's the bottom. Perfect. So in other words, what I need to do is I need to move these up and down by factors of 2. Now, one very messy way to do this is I can take a random value between 0 and 1. Or let's actually make it from like -6 to 6. So it can go, remember we're going to divide by 2 essentially. So it can go a maximum of 3 blocks up and down, or it can stay the same. I want to make sure that this is going to be a factor of 2. So maybe we can actually think about this backwards. So here's what I'm thinking. I'm going to multiply this by 2, which is actually going to make it bigger. So I'm going to make this -3 to 3. And we want to make sure this is an integer so that it's not having any numbers in between. So it's either going to be -3, -2, -1, 0, 1, 2, 3. And then we multiply it by 2. So we're going to make that exclusively the z component. Now, this should work, but I think it's going to look a bit awkward. Okay, so it looks weird from our side view, but if I go over here and render it, it should, in theory, be doing exactly what we said. Yeah, from the top view, it looks perfect, and then like that. So maybe I could go from -1 to 1. And that looks a bit more contained. The point I'm saying is this is the correct methodology. However, there's not like nice terrain, right? I want it to almost be smooth as it goes up and down, etc. Not the way it is. So to do this, instead of a random value, all I'm going to do is I'm going to use more of a smooth source of randomness. And this is kind of similar to what we just did, but because noise texture goes between 0 and 1, I'm going to increase that. And then more importantly, I need to make it discrete, because if I don't make it discrete, let me show you what happens. So right now it is moving all of them up. Let's think about why that is the case. Is that, yeah, that's a issue of the noise texture. So as you increase this and more, and more. Is this a normalization issue? Yeah, it is. You can see it creates, it's a little hard to tell, but it's making smoother landscape. However, can I soften this just a little? Yeah. It's making smoother landscape, but some of the blocks are like halfway up. You can see that there's like a non-integer gap there. So very importantly, just kind of like our coordinate system, we want to either round up, round down, or just round in general. I'm going to go for the floor function. And now, that's looking a bit better. Maybe we can also kind of center this in the sense that I'm going to subtract by 0.5. Remember, this goes between 0 and 1. So subtracting 0.5 makes it go from -0.5 to 0.5. Multiplying by 3 makes that bigger, and then we round down. So now it's basically a game of finding the right number. Yeah, basically the smaller we make the scale, kind of the smoother, okay, now we're getting something, the smoother the landscape is going to be. So you actually want to bring this, well, not only bring this down, but bring down the detail level. So now we're getting something much smoother. And I think you can kind of tell what I'm saying here. So there we go. We have nice terrain, And then as I increase this to 64 by 64, now it's looking much more like a Minecraft world with kind of like cross sections, which are going to exactly, by the way, they are going to exactly correspond with this noise texture. Okay, so imagine that, and then that should have lined up. I don't really know if it did, but so you can modify the height. Let's make an integer. Oh, no, we always want to multiply this by 2. Oh, wait, do we? No, we have multiplied by 2 here. So let's make an integer. This integer is basically going to be the height. So when it's 0, it's level. And then we can make it more and more like that. Okay. And now the question is, can we still play on this? Remember, there's a bit of an issue. So let's see. Walk navigation. There's a bit of an issue in the sense that I think gravity works, but you can clip through objects. But if we just kind of ignore that and use our jumping mechanic, which might have too much momentum, so I'm going to slow us down a little. Yep, it looks weird, but it should work. So I'm going to make our jump height maybe just a bit taller. And it looks like you can tap it or hold it down, which is nice. I'm going to make it even a bit taller, a bit shorter. And now, it's hard to get this exactly correct. But now, we kind of have a playable Minecraft game. Other things to consider is that this looks a bit weird, but that's because our, I guess, field of view is strange, right? So if I make this 30 millimeters, now it's going to look a bit more like Minecraft. And I think additionally, what's making this look weird is I think we're exactly the height. Oh, wait. I need to enable gravity. We're exactly the height of the ground. Do you see what I'm saying? We're exactly the We're exactly the height of the ground. The character is not 0 inches tall. I don't know if this is. I don't know if there's a control for that. I don't think. Let's see. It says Z is axis correction, but I guess I don't know how to do that. So we'll figure it out. But for now, we have our terrain generator, and I want to see if I make this extreme, what happens. Yeah. So you can get something like that. And the other thing I want to mention is that right now there are no gaps, right? So if I make this a bit taller, you will see a gap here. Because right now it's kind of like a continuous surface. I would actually like to have that so we see some dirt-only blocks, not just grass blocks. So let's think about this. If I multiply by 4, yeah, now you can see those gaps, but the gaps are everywhere. So I somehow kind of want to randomly say either do that or don't do that. So in other words, what I can do is I can pick 2 numbers, 2 and 4, right? 2 looks like this, 4 looks like that. I don't want 3 or anything like that because it has to be a multiple of our block height. And I'm basically going to randomly choose between these using a Boolean. So let's see. I'm going to connect that here. Okay. And let's change our probability. So this is a 2, this is a 4, and this is somewhere in between where it's going to have some gaps, which is fine, right? Is that fine? So I think from the top view, it should, yeah, from the top view, it should still be fine, but I guess some blocks are going quite low. So, we could remedy that by not subtracting by 0.5. Is that correct? Let's think about it. So from the top view, this is an exploration, you know, I haven't done this before. From the top view, it's fine. And then I need to stop doing that. From our gameplay view, that is not fine, because you can also go down, I suppose. We don't like that. So I'm going to keep this leveling. And what happens if I change it to ceiling? It just kind of rounds it up a little. Okay. So I believe we could kind of do a bit of an offset or something like that by like adding by 1. So let's see if I do 3 and 5. No, that just makes it more extreme. What I can do is I can add right here, add somewhere, and this will move them up and down. I don't know. But for now, let's ignore that, and we can come back to it. What I want to do is, now that we have these exposed blocks, although again, the issue is some of them, it seems like none of them go exactly up. What if I make this -4? What does that do? Oh, it makes them super tall. Makes them super tall. So 2 and -2. -1. Wow. We're going to have to solve that. But for now, we'll keep it like this. What I want to do is I want to spawn dirt blocks underneath. So each one should kind of create a pillar. And I'm going to need to think about... I feel like the answer is obvious, but I need to think about how to do this. I mean, let me just do one more pass. So we have a noise texture going between 0 and 1. Now it's a -0.5 to 0.5. I am multiplying by our number of, like, cross sections. Okay? So this could be negative whatever to whatever. I'm then rounding it up, and then I'm going to make sure that it's level by a factor of 2 or a factor of 4. I'm just trying to figure out why... Oh, there we go. Okay, if I change this to add, it seems to correct itself. Still looks a bit wonky, but we can figure it out. Maybe this should also be a sense of a noise texture, because that makes it more smooth anyways. So let's see. I'm going to... So basically all I'm doing is I'm changing my sources of randomness, yeah, that seems nicer, to nice smooth numbers so that it doesn't look so janky. And that should do the thing, right? So it's either going to be greater than 0.5 or less than 0.5, so that should separate these roughly in half. And that will mix it. So basically what I'm thinking is I want some of these to be 2, some of them to be 4, and we're going to mix it randomly. I guess I want to normalize this. And now we're going to get more interesting terrain, okay? So there's a difference. Either way, now that we can see, so this is why it's better. Now we have a block above others, so if I draw blocks underneath it, we're going to be able to see them. At least that's the theory. Okay, so let's move on. How are we going to do this? Well, right now what we have is we have a dual mesh that we shifted, and this is our terrain basically. And I want to make sure that underneath each block there are more blocks. So you could almost argue, and I'll show you what I mean right now, if I was to take another set position and I move it down by -2, I believe, we'll check, and then I join these together, you can see it makes 2 layers. So before, after, and let's kind of see that. Yes, so now we're getting blocks underneath it, although of course it is going to be a grass block. But the more layers I do this with, and don't worry, I'm going to do this in a more sensical way, the better this is going to look. Okay, so that is the idea I want to go for. But of course, this is going to go down 16 or 64 blocks, whatever a chunk is. So I don't want to do this manually. In fact, I want to automate this process. How would I do that? The way I would do it is I'm going to take a mesh line. Now follow me here. What is he thinking? A mesh line is basically just that. It is a line that is composed of points. Right now it's composed of 10 points. I can make it 11, 12, whatever. They should have a height of 2. So you can imagine there's a point here, 2 above there's there, 2 above there's there. And on each one of these, I then want to instance everything we've generated. Okay? So let me kind of show you. Remember, this is our terrain. Let's kind of do this in solid mode. This is our terrain. That is what we are going to instance. So now we have stacks of our terrain. Okay? And then instead of using this to generate the blocks, I'm going to use this to generate the blocks. Okay? Little bit messy. And I'm not talking soccer. But you can see that this is working quite well. Now, one thing to know is that you can see it's like just a tiny bit slow. Let's make that more extreme so we can see what's going on. 128. You can see how it's going very slow, and it shouldn't, because at the end of the day, we don't have that many points, everything considered. Blender can handle millions, and that's because we are taking an instance and then an instance of an instance. Blender doesn't like that too much. So if we realize one of these instances, so we had something like this, and now we turn it into actual geometry data, you can see the difference there. Now it shouldn't be as big of a deal. Yeah, it's going much faster, and if you do another realization, well, now we have its own issue, but you can see what is going on here. Okay, so now basically the issue is, well, one, these are not all the same height here, but we'll deal with that later. So that's one issue. But another issue is, of course, some of these should be dirt blocks, some of them should not. In fact, we actually know exactly which ones should be dirt blocks. If we look at our mesh line, the very top of this, the very top point, is where there's going to be grass, and then for our purposes, everything beneath it, I know it's a bit different in the game, I think, is going to be dirt. So we can kind of isolate this in a certain way. Here is how we are going to do that. So we have our mesh line, and for that, I'm going to create an attribute. Okay, this is basically going to be like, I don't know, we'll call it grass, question mark. And this is going to say whether or not it's a grass block. Now remember, it's going to be the very top point. If this is composed of 10 points, you can see the index goes to 9, and 9 has the tallest height. So what I can say is for when the index is equal to 9, in other words, the top one, we can swap out these numbers later, then grass should be equal to 1. And then I'm going to feed this in here, and that gets fed in there. And what I want to do is I want to make sure that I can isolate that attribute even after, if I can zoom out, even after all of our instancing. So I'll show you what that means. What I want to do is I want to view this on a instance level, and I want to check our named attribute. Which attribute? Grass, question mark. And there you go, we've isolated it. So again, we took our mesh line, we isolated the top one, and then as you move them through instancing, it should be fine. Now again, it's running a bit slower than I would like, and maybe that's just a Blender limitation, but I'm trying to see, yeah, that's kind of it. I want to see if I can get a significant speed up. So that's fine, although now that when we realize our instances, now we get this issue where we kind of lose all of that data, and that is something I'm going to need to think about. But that is a good start, okay? So now what I can do is on a instance level, we're going to make this look, we're going to do different logic in a second. But on a instance level, what I can do is assign a material, right? Even after we do the grass, I can assign a material after the fact. So let me show you what I mean. If I do material, set material, I can actually, in some sense, swap out what block it is because we just did it on a material level. And I can do this, I mean, based on any kind of selection. So, I don't know exactly what's up there. Maybe I need to evaluate this on a domain level and do this on instancing. Well, I'm going to need to think about that. But either way, we can assign this on a material level. So I basically want to use our attribute from before to basically decide that. So in fact, we might need to do a bit of clever work here to get that working. But for now, let's get our grass attribute, which again looks like this. And I want to kind of use this to assign our material. But I think the issue is maybe we need a backup material. So maybe like, how do I say this? So this is I guess it's not even applying our thing to begin with. Okay, here's what I'm going to do. I'm going to separate our instances, so we're kind of rerouting. I'm going to separate our instances into two categories. Now later we can optimize whatever, but we're just trying to get it to work now. I'm going to separate geometry on an instance level. So we have all our instances, and again, let's see what's going on here. We have all of our instances, and I want to make sure that some of them belong to one, some of them belong to another. Now, I guess the issue I'm thinking of now is each instance is the entire layer, but that's fine. Okay, well, let's try it before I go too deep into the weeds. I'm going to take the named attribute that I keep deleting, grass. We're going to use this as the splitter. So if I look at one of these, it will separate the top, the other one the bottom, or everything except it. And I think that should work. I think the issue is I need to be using a switch material, right? Okay, sorry. Before we do anything, I just want to check if this works. So let's say we have dirt, let's say we have grass, and this is our attribute that switches between them. Oh, it really doesn't like that, does it? Because it needs to be, okay. We'd need to do a repeat zone. Either way, okay, we've been on this for a while. So this one should be assigned the grass material because it's the top level. And then hopefully, if we now isolate the bottom level and make it dirt, and then we join them at the very end, this should work. Yes, okay. So you can kind of see what I've gone for. Now this isn't like perfect. I mean, it works, but it's not perfect in the sense that it kind of looks wonky. So what I want to do is basically change our numbers that kind of determine that. So you could kind of do this for ages, but for now I'm just going to pick some random numbers. But you could kind of figure out what looks right to you. Okay, so this way we don't get too much of that. Okay, cool. Now the next issue I'm seeing is, again, this is playable, but it runs so much faster when I realize the instances. Although now I'm seeing that we've set the material. Now that we've set the material, seems to fix it? No. It fixes it except for the grass block that cares about its coordinate system. So here's what's happening, by the way. Basically, we have a cube in 3 dimensions. And it's going to use our generated coordinates to basically make this line that separates grass from dirt. If it does not have those generated coordinates, then we're kind of screwed, right? Because it's just going to look like it's one color. So we somehow need to keep our generated coordinates. And I'm thinking, if basically all this boils down to taking a single cube and then like instancing it in a bunch of places, so it kind of ends up like that. If we could kind of store, that's exactly what we're going to do. If I can store the generated coordinates, then we can use them later. And it turns out that if you use, I think we want an offset position, but for now let's just see if it works. I'm going to use position, and I'm going to store gen, or let's just call it coordinates. What I want to see is if it actually keeps that. So let's see. We have all of this. We know this is fine. But now I want to realize instances, which again is going to break it. But now I want to see if it kept the attribute. So if it works, it's going to look like a repetition of a bunch of generated coordinates. So I want to take our named attribute, which one? Our coordinates. I want to view the instances in the light of this coordinate system. Make sure that this is on a point level. Oh, okay. This needs to be a vector to view it. Okay, so that's actually what we want, because you can see it looks kind of like, oh, everything's repetitious. But this is actually fine, because now each one has its own coordinate system. You can see it's a bit offset, but to be honest, I don't know if that's going to be an issue. But let's find out. So because this kind of breaks our material, of course, we're going to need to go back to our, well, let's kind of zoom out of here. What I need to do is I need to go back to my materials. mainly the grass one, and instead of generated coordinates, which this is all based off of, I need to bring over our attribute, which goes between geonodes and the other thing. It was called coordinates. Let's see if it transferred over. In fact, it did. And now I'm going to use this as the coordinate system. What a way to say that. Such that now it's going to be a little hard to tell. But that should be good. Now I'm seeing a bit of an issue, which we'll resolve in a second. But you can see that's definitely a fix. Now, what is the issue? The issue is we're taking a cube. Imagine this is on the world origin. This cube is centered here, and we're just taking its position. Well, if this is a 1x1 cube, or I don't remember what it is, it goes negative 0.5 on the x and positive 0.5 on the x, such that this point is the value 0.5, I guess like 0 on the y, and 0.5 on z. Basically, the issue is this should be like a 0 to 1 kind of situation. So I need to kind of offset this in a way where it's going to work. Well, luckily for us, I can just view the coordinate system, and I need to kind of offset it so that the center is more so in the corner. The way I'm going to do that is I'm going to offset with a vector math, so you can see that that is what it's doing. And I want to either add or subtract by 0.5 or maybe by 1. That kind of looks good, promising. Yeah. So I'm going to add by 1 because maybe it's a 2x2 block. Let's actually check. That was kind of the main issue. Yeah, it's a 2x2 block, so to shift by half, right? Half of 2 is 1. That should fix it. And now if I use this as the coordinate system, it's not going to look as wonky. Hopefully. What I'm seeing here is that we've gone a bit too far, which is strange because it looked fine here. Maybe we need to add by 1 and then also scale by 2, or sorry, divide by a half to kind of scale this back down. That also seems promising, so let's find out if that helps. And that seems to have done the trick. Okay, so now we're kind of back to shading error land, and I wonder, I mean, that's definitely an Eevee issue, but I wonder if we can resolve this by just like shifting numbers a bit like we did before. I believe, oh, okay, there we go. I believe if we just make this 0.99999, it will solve it, but effectively change nothing. Okay, so that is our terrain. And kind of the last thing, maybe we'll do trees in a second episode because this is running. How long is it running? We're almost at an hour. Let's kind of finish up here and then we'll do the thing. I want this to be, what is this right now? It's, well, it needs to be 65, but it's 64 by 64. Therefore, I want this to also have a depth of 64. Now remember, the reason that I'm outsourcing this is if we have 10 points, I needed the 9th index to get the top 1 for our material switcher. I want that to also be procedural. So I'm going to make it 64 points, and I'm going to subtract by 1, because that would be the highest index. And now, it's actually not that laggy. Now we have this. Now, one issue I'm seeing, I guess I didn't notice it before. One issue that I'm seeing is now, remember how we talked about repetition and how we broke that? That seems to not apply to our grass. And I think what's going on here is we're using this randomness to do it. However, now this is all one object, so it all kind of has a single number. So what I'm going to do, so again, everything here is one object, so it only has a single random number, so there's no variation. There's a cheat we can do. Instead of that, I believe it's called geometry. It has this other input called random per island, which, does it not work in cycles? Or sorry, in Eevee? Either way, in theory, this should kind of fix it. Let's see if it fixes it in cycles. Yeah, it does. This should fix it because Each cube is actually separate. We just have instances. They're not connected, which means they're their own islands, which means they should have a different number. But again, it seems like we're going to have to cheat this. But if I want the island and I want to randomize it, why not just brute force that in Geometry Node? So remember, we have our material stuff, and now, yeah, now you can see it's really laggy. So we could find optimizations, but this seems to be fine. When we realize them, they become geometry, so we can go from, how much? 262,000 instances to, now you can see why they use the chunking system in Minecraft, to 2.1. Now, by the way, once we get, like, in this, I can hide the cubes that we don't see to save on render time, but now we have 2.1 vertices, million vertices, which means we're on the geometry level, but still, each one of these cubes is separate. Wow, that's something. Meaning, if I want to make my mesh island command, why don't I just use the mesh island here? So what I can do is I can store this as the island index. Yes. I'm going to call this island. And basically what this is going to do is it's going to tell us which island it's on. It's going to go from 0 to 1 to 2 to 3, etc. But then we want to take this and randomize it. So you'll see what I'm thinking in a second. So it's getting dark out. We've gone for a while. If I take the attribute called, what did I just call it? We're changing the island. If I look at this, it should look very, very white. Oh, we're on the dirt. Maybe. If we look at the attribute island, it's going to be like basically pure white because basically each one of the indices, each island is going to be 1 or above, which turns out to be pure white. If I take this and I divide it by a big number, you'll see there actually is detail in here. As you can see, we're starting to get that detail. It's just that the numbers are so big that it kind of looks white. But either way, to randomize this, it's already like blocked out for us in the sense that we can just drop this through a white noise texture. Now we've randomized it, and now all I need to do is use this as our replacement for the random per island. And now we should get, I'm seeing shading issues again, we'll talk about that. But now it seems to work. Now, it seems like Eevee really doesn't like this. How did we fix white noise before? I'm trying to remember how we fixed it before. Is it by, like, shift? I mean, it seems like everything we do, as long as we shift it by, like, a tiny, tiny number, it seems to help, but maybe that's not the case here. So I'm trying to think about what we can do. In fact, we can actually make this one-dimensional without losing anything, because we just care about a single random number. So that works, but we're still getting shading issues. I could either shrink the instances a tiny bit, which seems to work, or I'm trying to remember what I did last time to resolve this. It seems like I added a bit of randomness, and I think a big part is we did this like rounding down kind of thing, right? So remember when we had this set to floor, we had many more shading issues. So what I'm seeing is it does not like this like uncertainty of the white noise. So maybe if I was to really constrain it, so I'm going to like, I mean, this is going to break it, but I'm going to round it down. In theory, yeah, so it's all the same now because it's all rounded down to 0, but it's not having that issue. So instead, I'm going to, so basically, if I have a spectrum from 0 to 1 of the white noise, it doesn't like it that it can be anywhere in between. So if I divide this into finely divided chunks that are, we're basically rounding to the nearest 0.1 or something like that, that should be deterministic enough. So I'm going to snap this to, well, you can see 0.5 breaks it up a little. I'm going to make it 0.1, and now in theory, doesn't like that either. But the idea of this is now we now we've constrained it a little. But it does seem to like floor, so let's see that. I'm going to multiply by 10. Maybe we can use this. Let's see. We're going to use the floor function, and that has not saved it. Boo. Yeah, it really doesn't like the uncertainty, does it? I'm going to need to look into what does that, because it seems like there's a bunch of tiny fixes. But for now, we're either going to ignore it, or if I can fix this on a geometry level, that's going to be fine too. So let's see. We're getting this glitchiness. If I make it 0.999, that does not solve it. Okay, so I think we are going to kind of not care about that in the moment. It might just be kind of like a render setting error. Yeah. It might just be like a render setting error. I don't really know, but whatever. If anybody knows, email me, because I'm not enabling comments for a while. Okay, we're almost done with this part. I'm just gonna start adding in some details. In fact, you could argue, like, why not just kind of play this in cycles, but I'm getting that tiny bit of lag, which I don't like, so that's why I'm using Eevee. It's that real time. Okay, I want to add a bit of stuff. For the grass, I'm going to take everything we've done, and by the way, there's more details we can add here, but again, I'm thinking about making this a course. I'm going to send it through a principled BSDF. The reason for this is so that we have some of that lighting, at least in theory, we're going to have lighting. And I don't really know how Minecraft is lit, but I'm just going to use a sunlight, which is somewhere. Where's our sunlight? Sunlight. Oh, there you are. It's because I'm like upside down. Okay. I want to basically rotate our sun so that it looks good. It might be kind of like a indirect lighting kind of issue. But you can see now we're getting our nice lighting. And maybe if I bump this up, it will look better. Okay. That's looking better, but we're getting like really harsh shadows and stuff like that. So I know when we increase the angle, we're increasing the softness of the shadows. So check this out. Now it's like perfectly soft. So we're going to soften the shadows, fine. Let's see if we can add more detail for free. So ambient occlusion seems to do nothing, but that just might be the setting. Let's see. Ambient occlusion, look at a bigger distance, make it way stronger. I don't know if ambient occlusion does self-ambient occlusion or not. So we might also have to forego that. Boo. Screen space reflections are free to enable. Depth of field, we could actually, if we're moving the camera, depth of field might be nice actually. Let's try that. So I'm going to add in a camera such that we can move the camera. So this is actually going to be our like player in some sense. And what I want to do is if I enable depth of field in real time, then our player should have depth of field in real time. It's kind of like adding on-screen effects. So I'm going to bring down the field of view. You could actually get crazy with this. Some people play Minecraft like that. I'm going to take the depth of field, which I swear exists. We're going to take the depth of field, and we're going to bring down the focal distance, such that you can see there's a bit of a light kind of blurring. So I want to be able to see a bit in front of me, and you could bring down the thing. Just find the numbers that you think look good to you. Yeah. So I'm going to bring up the distance. I'm going to make this less intense. And now we have very subtle depth of field in our game. Such that if I now play this, how did I do that? Walk navigation. It should still, yep, it's still going to work, but now we're going to be stuck in our camera view. And I can even enable gravity. Look at that. So maybe if now we have our camera and we do like a bit of an offset, right? So it's like a bit taller, and then we can do this. Now, I also want to add better controls, because right now it's looking weird. But that's cool. Okay. So, email me if you want this to be a series. I might make it semi-free, semi for patrons for like a couple dollars. Because I think it's like, if this took an hour, like, come on, dude. Making all of Minecraft. So, there you go. Let's see if I can do any final modifications before we get out of here. By the way, I'm going to put this file on Patreon, okay? I just want to mention that, because I know people might want it. Contact shadows? Do we like contact shadows? What does that look like? I don't know how that works. Maybe it needs to be paired with ambient occlusion. Either way, I clearly have some learning to do when it comes to the, I was going to say the game engine, but really it's going to be Eevee. But another cool thing I just want to say is now that we have, yeah, we should have like active viewport compositing. We can add all sorts of effects. So here's just another idea. Like let's say I wanted to add a kind of like a lens distortion. Let's talk about it like that. I'm going to render a single frame here. And all I'm going to do is I'm going to apply, I think this is the case, I'm going to add some lens distortion enough to be visible. Let's actually distort it in the other direction. I'm going to make it more obvious. So we have our distortion. Now we should also have it in the viewport, but that might be a cycles only feature. I don't know. Nope. We can have it in the game, boys. We can have it in the game. Disabled, enabled. We can also do color toning. Wow. If only we could have real life motion blur. Although maybe I'll find a way. Either way. I just want to remind you that this file is going to be available on Patreon for $5, or really $5 will get you anything on my Patreon, which is like 3 to 4 years old. Wow, if you look at the beginning of this video, it should be brighter than it is now. The sun has began to set. So, please join the Patreon, man. Like, this was a video. And yeah.